going to do is check remember the first problem I gave you where we did it without having this formula? I'm just going to show you. I'm going to do it again with the formula to get the same answer again. Okay? So let me just kind of recapitulate, and then we could go through it today. Okay? So the method that we covered today is called variation of parameters, and it's a technique that will get you the particular solution, not having those two restrictions that the method of determining coefficients had, namely the equation can have variable coefficients, and also the right-hand side doesn't have to have a finite family. And by the way, I illustrated for a second-order equation. This works for nth-order equations also. Okay? So don't think it's just for second order. Okay? And the method basically is the following. You first find the solution to the associated homogeneous equation. You know how to do that, at least if it's constant coefficients. Okay, later on, one of the topics we're going to do is solve equations that have variable coefficients, but I guess most of the homework problems and things I'll do in class will be constant coefficients, and it's the right-hand side that will have an infinite family that's going to preclude using the other technique, but it works in any case, okay? So you basically first construct the solutions y1, y2 to the homogeneous equation, okay? And then, reasons called variation of parameters, we know the general solution to the homogeneous will be c1, y1 of x plus c2, y2 of x, where c1 and c2 will be arbitrary constants. Method of variation of parameters replaces those constants by functions of x, u1, u2. And again, as we noted several times, we only have one equation to satisfy, and we have two unknown functions, u1 and u2. So as soon as we take the first derivative, we're going to simplify things, and we just make y1 u1 prime plus y2 u2 prime equal to 0. That's really the first row of your Wronskian. That's where that's coming in. Okay? And then we just crank out yp double prime. Okay? You plug it into the equation, and you find out that you get this simultaneous system. And then there's the solution. So actually, in practice, you have to go through all this. Okay? What would you do in practice? If you had this formula in front of you, okay, you would have to get the homogeneous solutions y1 and y2, okay? You'd have to remember at least the form of yp. It's u1 y1 plus u2 y2, and then you jump immediately to this over here, okay? I know everything on the right-hand side, right? I know y1, I know y2, I know their derivatives, obviously, so I got the Wronskian. You know your right-hand side, and the question is how challenging these integrations are. Okay, you integrate that, and again, you don't need the constant of integration in there. Just get the simplest u1 of x that you can, the simplest u2 of x that you can, and then come back to your yp, which is over here. Okay, and again, remember why don't you need the arbitrary constant on u1 or u2? Because that would add a multiple of y1 and a multiple of y2, and that gets absorbed in the homogeneous solution when you write down the whole thing. Okay, and I think there's some homework on this that's posted, and actually, you have enough now to do the homework, but if you want to wait until we do some examples in class, feel free. And again, the homework you'll see is not going to be collected. Okay?